filter circuits. We know that the rectified output contains ripples. If we want to remove that ripples, we use a filter circuit. A filter circuit is a device which removes the AC component of rectifier output but allows the DC component to reach the load. So we are giving an AC input to the rectifier. The rectifier rectifies and we are getting a DC output like this. It contains ripples. The filter circuit uses to remove those ripples and obtain a perfect DC signal. There are mainly three kinds of filter circuits: capacitor filter, choke input filter, and capacitor input filter or pipe filter. In capacitor filter, we are using a capacitor which is connected across the loads. We know the reactance of a capacitor Xc is equal to 1 by 2 pi Fc. For direct current, frequency is 0. That means the reactance is infinity. Therefore, a capacitor offers high reactance towards direct current and easy path for alternating current. So we can design a capacitor filter like this. A capacitor connected across the load and the output of the rectifier is given here. This is the output of the rectifier. So the output of the filter circuit will be like this. Let us see the working of this capacitor filter. The dotted line gives the input and this is the output. So when the rectifier output increases, the capacitor charges. While the rectifier output becomes lowering, capacitor discharges through A to B. And meantime, this rectifier output increases. That means the capacitor again charges to its maximum value of Vm. Then rectifier output decreases and that time the capacitor discharges through C to D. In this way, we are getting almost a DC output. Let us analyze this capacitor filter with a bridge rectifier. So this is the bridge rectifier which is connected with a capacitor filter. The output is this one. If we compare it with the input, so we are getting almost a good direct current. In choke input filter, we are using an inductor or choke which is connected in series with the rectifier output, and also a filter capacitor is used. The reactance of the inductor is 2 pi FL. That means XL is equal to 0 for direct current. Therefore, an inductor offers high reactance towards alternating current and easy path for direct current. We can design a circuit like this: an inductor in series with a rectifier and a filter capacitor here. The inductor allows DC to pass and very high reactance to AC. Therefore, most of the component reaching at the point 3 will be dominated by direct current, and the AC component at the point 3 will be bypassed by the capacitor C. Okay, therefore, what we are getting through the load is dominated by direct DC. The output is looking like this. This is almost a perfect direct current. We can analyze the same with the bridge rectifier. This is the bridge rectifier and this is the inductor and capacitor to form a choke input filter. This is the input signal I am giving. Input means the output of the secondary of the transformer. What I am getting is this one. The output of the filter circuit is this one, or if you combine, you can see this is the capacitor input filter. Uses two capacitor and a inductor in series. This capacitor is connected across the load. So this is the circuit, C1 and C2, and L is the inductor. So it works as before. The inductor allows DC to pass and the AC components are bypassed. So the output what we are obtaining is dominated by DC component. If you examine the same with the bridge rectifier, so this is a bridge, this makes a pi filter. It is also known as pi because it looks like the Greek alphabet pi. The output is this one, and if you combine, the output also varies with the input signal. Now we can go through voltage multipliers. So diodes can be used to make voltage multipliers. Voltage multiplier is a circuit that delivers DC voltage output, which is a multiple of peak of AC input voltage. These kinds of circuits are used in high voltage low current devices. Half wave voltage doubler. A half wave voltage doubler means it have a multiplication factor 2. So this is the circuit. It contains two diodes and two capacitors connected in this way. Let us analyze its working. So this is the input, so the Vs max. At the first cycle, this point is plus and this is minus. At plus, the diode D1 is forward bias, or diode D1 conducts, and diode D2 is reverse bias. The path in this way. So at that time, the capacitor C1 charges to its maximum, that is charges to Vs max, okay, or the capacitor voltage Vc1 is equal to Vs max. In the next half cycle, this is positive, therefore the D1 is reverse bias and D2 is forward bias, therefore it passes through this way. Okay, therefore the capacitor C2 charges to maximum Vs max. So ineffective, here we have a Vs max and here we have Vs max. So if you measure a voltage across the capacitor, we are getting a 2 Vs max plus Vs max, that is 2 Vs max. Let us analyze this using the Kirchhoff voltage law, the outer loop. So here we have the this is plus, this is minus. Minus Vs max, Vc2 is plus, and here it is minus Vc1, or minus Vs max minus Vc1 plus Vc2 equal to 0. From that, Vc2 is equal to Vs max plus Vc1, but Vc1 is actually Vs max, therefore Vc2 is equal to Vs max plus Vs max, that is 2 Vs max, that we discussed. Therefore the voltage across C2 is 2 Vs max. So we can call this as a voltage doubler. Now voltage stabilization. I told you earlier, the output of the filter circuit depends on the input, depends on the changes in input signal. But in many electronic application, we require a stable output. So a voltage stabilizer stabilizes the output voltage. Let us study about Zener diode. Zener diode is a properly doped crystal diode which has a sharp breakdown voltage. The Zener diode is always reverse biased and it have a sharp breakdown voltage. It's called Zener voltage. When it is forward biased, it is just like our ordinary diodes. This is the VI characteristic of Zener diode. See, the first quadrant is same as our PN junction diode, but in the third quadrant, at this point the current increases sharply but voltage remains constant. This is called VZ or the Zener voltage. Okay, this new value or this Zener voltage. So voltage does not changes but current changes. So we can use it as a constant voltage source or voltage stabilizing device. Zener diode can be used as a voltage stabilizer or regulator. So this is the circuit design. It have a series resistor Rs. The unregulated direct current is given in between these 2 points. So output is taken through RL. So here I is equal to IZ plus IL, and the Vin, if you voltage across diode, that is Vz plus voltage across this resistor I into Rs. But I is I plus IZ plus IL. Therefore Vin is Vz plus IZ plus IL into Rs, or Rs is equal to Vin minus Vz by IZ plus IL. But Vz is actually the voltage, output voltage itself. For Rs is equal to Vin minus Vout by IZ plus IL. In that way you can calculate Rs. So this is a circuit, a 12 volt input and a 100 ohm series resistor, Zener diode, and a load resistor, what you are getting is this one. So this is a 5 volt Zener diode. So whatever volt you are given, its output will be a maximum of 5 volts. In that way you can say the output voltage is stabilized. Okay.